Hello and welcome to Lesson 1 of Database Design and Development for National 5 Computing Science. This is what we're learning today, just the basics, nothing that's in the course specification, just the basics. What is a database? Currently they are computerized organized stores of information, but they didn't always be that way. The biggest benefit of an electronic database is how fast and easy it is to search and sort the information, and how convenient it is to add and amend or delete data that's in that database. It's also super easy to transfer an entire database or make new copies or delete the whole thing. You may be wondering, what is this picture? This picture is the common representation of a database. I think it's because this is what a hard disk drive looks like. It's a stack of platters, and this is what stores all the data. But after a little bit of Googling, I think this may be the original origin of this image. But whenever you see this sort of stacked cylinder, it means it's a database. So let's look at the structure of a database. Previously, databases were stored on paper. Look at this. What a mess. You go to the doctor's office, tell them your name. They have to rifle through a stack of papers to find your name. Very disorganized. I mean, even if it was the most organized paper-based database on the planet, there are many issues with this. Finding things takes a long time. Resorting the database takes a long time. Inserting new records, deleting things. It's all very inconvenient. Making copies of that would take months. And if you moved office, that would also be a lot of effort, a lot of time. There's a lot of risk that you lose things. Just a horrible experience. Electronic databases are much nicer. They look much nicer. They're easier to find information to insert, delete, and all that sort of good stuff. This is the main structure you'll find in a database file, and this is the table structure. So the whole thing is called a table, and within this table, it contains all of the information related to a certain thing. This table contains information relating to people, and these people are dog walkers, as you'll see as we get into this. In this table, we have columns, and at the top of each column, there is a column heading. These are called fields. So we've got tables, we've got fields, and each field contains or is the heading for a single piece of information. So we've got the forename field, the surname field, and so on. And each row is also known as a record. So this is Adam Ant's record. We've got Biffa Bacon's record. And that record stores all of the information related to that one particular instance, that one person in this case, the dog walker. In a single file, we could have multiple tables. Here we have the dogs that these walkers are going to walk. Some cool dogs in here. Now, when you're creating an electronic database, you might be tempted to just keep it all in a single table. This is known as a flat file database, a single table. But there are problems with this. Look at this. Adam Ant, he walks 2 dogs, but there's an issue. We are repeating some information here. You can see further down, Eve walks 2 dogs as well, Layla and Poppy. You'll also notice there's a bit of repetition here. There are 2 poppies. Which poppy are we referring to? Are they the same dog? Do these people share that dog? And also the repetition causes issues, like if you accidentally mistype on one of those records, if this poppy's owner phones up the dog walking service and says, oh, Poppy's not coming for a walk today, tell Eve that we don't need her, they're going to phone this number and it's going to be a dead line. So this is an issue related to flat file databases. How we fix this is using relational databases, where we have one table for one thing. So in this case, this thing is the dog walker. And then we create a separate table for the dogs. And these people walk these dogs, okay? So this is how we relate one table to the other. But you might notice there is another issue. Which Eve are we talking about here? Which Eve are we talking about? And also which poppy, because there's 2 poppies that are both Chihuahuas. Well, this is where primary and foreign keys would come in. A primary key is a field that uniquely identifies a record. A foreign key is a field in a table that's a primary key in another table. What's the point of a foreign key? It's to create links between tables. I'll show you an example. Here we have some primary keys. Now, when we're talking about Eve and Eve, we can know which one we're talking about using the primary key, the walker ID in this case. Likewise with the dogs, we have an ID, a primary key. This uniquely identifies each dog. So now when talking about Poppy the Chihuahua, we know exactly which one because we will refer to the primary key. So how do we relate a dog walker to a dog? That's where the foreign key comes in. Bloop. Here we can see that these walkers walk these dogs. Yes. So when we weren't sure which Eve it was that walked those dogs, we've got 5 and 6. Well, we know that it's Eve Evans that walks Layla the Rotti and Poppy Chihuahua number 4. And that Eve Smith walks Titus the Jack Russell. Hang on, is that right? I thought it was Adam that walked Titus. Never mind. Either way, you get the idea. We can uniquely identify a record using a primary key, and we can relate two tables using a foreign key. So there you go. You've learned the beginnings of databases. You know how they're structured. You know what primary and foreign keys are. And we're ready to start learning the course content that we can find in the course specification on the SQA website. Let's go.